Hello guys, this is Johan Forsblom and welcome to my isometric game tutorial part 5. In this tutorial we're gonna do some refactoring. We're gonna move some reallocation code for the components. We are gonna write a timer so we can do the sprite animation part. So first of all I'm going to give you a little bit teaser what things are gonna look like when we're done, and this is what things will look like. Here's our little guy running around on the screen, animating. And if we bump into something, he will stop moving. So this is what we are gonna put in today. So sprite animation. Okay, let's get started here, and we're gonna go into the allocation. The allocate more memory for components function here. And here I've done the first one already, and the position component. There's a lot of things, so basically we're just moving the code into each component here. So let's go to the next one. Take the velocity component here, cut that stuff out. It's just going to be repetitive, same thing all over again, so you will see what's going on here. Void component, velocity, locate more memory, and we are going to get in the scene, and we are taking in the component index. And write int a because we don't want to do too much work. And we take the component index there and here as well, so you know which one we are working on. And we take and make a pointer of this, and we are not going to return anything, so I think that should be it. Let's go build quick here and see if we have any errors. And we don't. Good. Component velocity, allocate more memory. Headers. Grab that little friend and throw him in here into the scene. Like so. We take the index in there and we take the scene. Let's go build and run and make sure this is working properly. And it is. We can get into the game. And I did forget one small thing there. We want to take the name of the function as well. Cool. Let's do the keyboard component here. Component input, keyboard allocate more memory. Take the scene in and the component index as well here. And the same thing all over again. We're gonna do a quick fix for another thing here. Well, not to fix it, just to change, basically. And did we forget anything? Okay. Build looks good. Component input. Oh, okay, we have an old file here. We're gonna delete this one. And to the H file here. Get the scene and the index in. Build and run. It works, we're in game. So if I don't do this, we're gonna have a fat, nice crash if we don't do the reallocation for the components. Input mouse. There we go, allocate more memory. Scene. Int component index. So we improve our code step by step. Did we do that in the keyboard part here? Hopefully we can do that again. Yeah, good. And we need this one as well. The pointer, like so. And let's have a check here. Build. Oh, get the old window up here for this last one. Return with a value, of course. And build. Works good. Input keyboard. Input mouse, right? And there we go. Hopefully this is gonna work as well. Well, but hopefully it should, because it's just simple refactoring of code. A little one. Yep, we are working. Render component as well. Render 2D. Component, render 2D. Allocate more memory. Component index. Good, you could build that. Awesome. Component render 2D allocate more memory to the render .h file here. Build and run. Oops. Yeah, this is because we don't have forward declarations here, so I think we have one in let's see if we can find one. Precision has it, so you can just copy this to friend. We just add it in here. Build. Yep, good. Build and run. And here comes our trusty screen. Cool. On the name tag component. Component name tag. And allocate more memory. Component index. See if this one needs a full declaration as well. Nope, good. Component name tag. Or it could, because it's not something we pasted in here, that we will get that thing. Build and run, and we're off as well. Good, works nicely. And then we take the collision component here. Of the system, sorry, we get to go into the component collision. Collision. Allocate more memory. Indexer as well as a parameter, and we do the same thing again. Do a quick fill here where we're returning 0, which we should not do, and grab that friend. Build. Well, can you do everything immediately? Of course. And scene. Like so. Yeah. And doesn't have the type forward type declaration, so let's get it from here and to the collision here. And then run. Yep, we are good. So that was the reallocation move of the reallocation code there. So looks a lot more nice now. Just one line in between here. So when we add more components, that's going to be a lot of scrolling. A small improvement. Okay. Then we should go into add the timer stuff here. Timer.h. Empty file, yes please. Timer.c. Close some of these old tabs here. If not defined. Define. And I get my notes up here as well. Type def struct timer t float current time Which basically is the current time, yeah. Float time log point in time to count from. Float time duration. How long the timer should count. For timer init, timer t, pointer and milliseconds. This function is like places the timer and set its duration. And then I have int timer update. This function updates the timer and resets it when it comes to its end, basically. Or we can perhaps call it timer check or something, I don't know. Ah, we just keep that as timer update. Timer time log equals to SDL. Oh, we have to include our SDL, of course. Include SDL2 SDL and include timer.h. SDL get text. Any time duration is equal to the milliseconds that we throw in. If we get the current time, timer current time equals SDL and get text. I'll spell this more. If the timer has passed its duration, the current time is largely equal to the timer's time log plus the timer duration. Then we will set the time log to position. Then from that, timer time log equals timer current time. So this is where we just reset it, and we return 1 if the timer has finished its duration. Return 1. Return false or rather 0 if the duration has not passed. So this is basically the timer. Really simple stuff. Held. Make sure we have maxed things up good. So let's close those two and get into our animation stuff. If you remember in the last video I included the animation .c file, but we're gonna write this from scratch because some things have changed. So and also I want you to be able to follow along. SDL standing out. Include SDL. Include string. Need a component animation. .h. And here we are going to delete everything as well. We're going to write everything from scratch for you guys. So we can start without actually the H file here. Here we go. Include. We'll have the texture and include the timer now actually that we just wrote. Component animation non-initial animations. Doing that 2 or something like that. Define animation. State none. Type of enum, and we have entity. Direction in the world. And to the world direction up. We're gonna have each of these. Up, down, left, right, up, left, up, right, down, left, and down, right. Just set it up really quickly, and I'm just doing this for extra readability. We could just say comma like this and it would start to count to 0 anyway, but we're gonna do everything with readability for those who don't know all the small details. And we're gonna need the forward declaration here, I think, so we're gonna grab this from mission part here. Just gonna copy that. Actually have it up here on top. Type def struct animation frame t, and this one will have SDL clip right. Clip rectangle for the animation. Frame time milliseconds. How long this frame should be displayed. Type def struct animation t. We're going to point it to the texture. We'll have a name for the animation as well. We'll have the frames, is the number of frames in the animation. Print frame to draw, and here we'll have our timer T. Frame time. So just frame time should be okay. Yeah. And then we have the component itself, type def struct. Animation T, animations, animation, state, entity, direction, and royalty, and direction. Directing the entity is facing I don't know if we're gonna need this. I'm gonna check my notes here, see if we need this one. No, we don't need this one. So we're gonna go with int num animations. Number of animations. Int max animations. Like so. Component animation T. Component new animation. You can have the component 3 animation as well. Animation T. Component animation. Component animation. Allocate more memory. Component index. And we will need the component animation. Create new animation. Animation in entity. Picture T. Animation name. Animation add. Animation frames. Num frames and int start with index and int time milliseconds. And we are gonna need animation frame time. Animation T. Let's copy some of these things here. Frame and word component. Where did that go? There we go. And get animation index by name. Animation name. Set animation state. Component animation T. Component animation. Like so, and we have the intensity and make sure that I'm doing things the right way here. Yeah, we're just gonna take in. It's gonna say sure which animation name, which animation state you want to set active. So that's the functions we need. And so we can build and make sure we didn't mess things up. Yeah, good. We're in here. Put animation.h back to the Z file. And we're also gonna need the scene. And we're gonna need the logger as well, usual. We'll allocate memory for the animation component. Malloc size of struct component animation T, multiply with the number of num initial entities, of course. If the memory allocation failed, log the error. Name for the animation component. Return no if that happens. Otherwise, we will just initialize. What? Initialize the animations for I. Non-initial entities. Look for all those and we go through them and we make sure that we are resetting the new animation component I dot animations equals null. Num animations repeat 0. max animations are gonna be 0. Animation state is gonna be animation state none, and direction is gonna be entity wheel direction down. That's a good start. And we will return the new animation component after we allocate it. Nice. Now I'm gonna write this as a friend here, so it's better if we just copy the code from, say, the condition or whatever. There we go. The component is still there, but we need to change these ones to the animation component here. Component animation and to replace the stuff here, and we say that this is in here. And that's for animation components. So, did we do everything right? I hope so. Build. Expected. Yeah, we have some commas missing here. Good. Build. Yeah, we need to set the log.txt here as well. Recent type deactivated. Well, these are of course going to be changed here, and they're going to use exactly the same things here. So this is going to be J dot. Let's copy these guys in here. Max animations is 0. Animation state is going to be animation state none, and J dot direction is going to be entity wheel direction down, like so. That's better. Build. Good. And here comes the next function that we want to get fixed up here. Some temporary buffer to hold our messages. Animation key. Animations. This is if we want to reallocate more memory, and this is animations is going to be a pointer to make things less, give us less typing, because we need some long stuff here. Let us know. We're gonna do some array function. And we say that the parameter is null. Oh. Write smashes to a run log.txt. turn -1. Hello? To file. Just copy this, we'll do same to the texture. Texture is no, and we have the animation name as well. The texture is no. And then we make a check here if the animation are not allocated, then we'll do that. If component animation entity dot animations is equal to null, then we'll allocate more memory for them. Entity dot animations equals malloc size of struct animation t and multiply with a component animation num initial animations. Remember, allocation failed. That is no, then we will just do our error stuff here. Just say that the animation has failed nicely. And we write that to log and we exit. If not, we will initialize the animation component. Entity dot max animations. It's going to be equal to the component. Animations, and we have a component. Entity.non-animations is going to be equal to 0. Revise the animations. Entity dot animations I dot current frame. It's a long thing. Frames equals to null. Frame is gonna be null, and we have our num frames gonna be 0, and we have our texture which is gonna be pointing to null. Allocate memory for more memory actually. Memory for animations. if needed. Animation entity dot animations is larger or equal to component entity dot max animations. We are going to try to allocate more memory. Another 5 animations. Entity dot max animations is plus equals to 5. Here we're gonna do the reallocation here. Point animation entity dot animations. This will be size of direct animation P. Multiply with the component. And come on. Animation entity dot max animations. When reallocation failed, we will say something like this. Could not allocate memory for animations. And here's a very important thing: we have to roll back the number of max animations here. Minus equals 5, so we don't say that we have more animations than we do, because that's not a good thing. If we did not fail, we will have to point the move the pointer, point the animations. New memory location entity dot animations equals new animations. Now we will initialize them. Height will be equal to the component animation entity dot num animations. That's where we start, and we go up to animation entity dot max animations. Loop through those, and we're going to say component animation entity. Exactly this is what we are going to say. So we're just going to copy that, fill that in, like so. And here is what we are going to use. For less typing, point the animations pointer to the animation. For animation entity dot animations. There we go. Okay, memory for the animation name. And animations and dot name equals malloc size of char string length of the animation name +1. We have an extra character for the end line. Sorry, if the failed, name is null, and we write them nice error message about that. Log the error to file. Animation name. Otherwise we set the name. Oops. Like so. Set the texture pointer. Animations. Entity dot. Now animations dot texture. Maybe equals to the texture that we just pointed into the function. We will initialize the frame timer to 100 milliseconds. Timer init. Frame time and 100. Increase the number of animations. And we return the use of the last created animation, which is basically this counter here, -1. That's better. And now comes the fun part. This is a nice thing actually. And I'm gonna boot up Krita in the background while we're doing this. Where we are typing so I can describe what's gonna happen. You're gonna need some variables, x, y, some loop variables as well. We're gonna need the width, like width and height. $512 for that. Texture size X. Check X actually. And check Y as well. Animation frame T frames equals null. And if the component animation, just grab it up here. Put it in null. Invalid. Quite long error in the function. Parameter is null, of course. It's null. Turn -1. This out of the function. This is what we're gonna do. If the component animation entity dot animations equals to null, if you don't have any animations. error in. Component animation. Send the animation. Pointer is null. I'm gonna throw in the entity here. We know which one is messing up. And it's gonna be sprintf here actually. Put in MSG. And I'm gonna write that out. Run log. That's a better one to copy right now. So if the animation index is larger to component animation entity dot num animations. The animation index is out of bounds. Then the number of animations. If number of frames is invalid, write to log. Pairing function parameter number of frames is less or equal to 0. Frames were not added. I'm just gonna have a little warning here just for fun. If you have more than 200, warning. And here we have to return out of the function, return -1 because that's really invalid. What's going on here? There you go. But the animations is correct. And for those who go in, well, it should be enough. And frame time looks like it's a lot less or equal to less than 10 actually. To me equal to 10. So why do I do this? Well, basically the accuracy of the timer for get ticks in SDL is around 10 milliseconds. So even if you go below that, it's not gonna do anything. It's not gonna work anyway. And we're gonna need some animations. Animation index dot texture, that is null. Add animation. Frame to animation. Texture is null. Should be component animation. We can put this on a new line. This is a long one. Component animation entity dot animations animation index dot name. There we go. Let me write that to the log as well. Sorry about that. Get width and height of the texture. Width equals to component animation. Entity dot animations animation index dot texture and the width. So we get the height. If the width is if the width of the texture is less than the width that we want to have for the animation, if you look up here, we're asking for the width and height. We're saying the width and height of the animation is going to be this width of this height, and the W and the H is going to be the image, so the texture width and height. So if the the texture's width texture width is less than the requested frame width, texture width is smaller than the animation width. Boarding. Here we have the width and the other one as well. Right, the texture width is W and the other one is width, like so. Width. Let me just copy this and remove that one, of course. The height. Like so, and we fixed the height as well. Now we're going to calculate the calculate number of frames that can fit in the animation texture. Fits in the texture basically. Texture size x is equals to the width with the texture divided by the width of the animation that we're asking for. Oh, texture size. Check X, multiply the texture size, check Y. And that fit in the image. Good. If the texture cannot contain all the requested frames, Animation, texture size cannot. Can only hold percent frames and parameter change this percent. Sorry about that, guys. Coughing a bit here. Here we can throw in the component animation, entity dot animations, animation index dot name, and we just throw in the max frame size, in the max frames and index image like so. Allocate memory for the new frames. Entity dot animations, and we get the animation index here. Frames is equal to malloc size of correct animation frame t multiplied by the number of frames that we want to have now. If memory application failed, could not allocate. For animation frames, animation percent s, and we copy that long thing here. It's already in there, so log that one, get out. Less typing. Point the animations. Point the frame to the frames. It's this one guy here, right here. Loop through all the animation frames. So here comes the fun part I'm going to describe to you real soon with Krita here. Start frame index. So what we're going to do here is Krita, and I'm going to make a new texture here quickly. Whatever. So here's our texture, and inside the texture we're going to have we got 3 rows here. For simplicity here. Okay. And in here we have like the first frame of something, and like an animation with 3 frames. So this is for me. On this row we have animation 1. Here we have 2, and here we have 3. So what we're asking here is that we want to find the start frame index. So if you say that this first here, this is 0 here, of course. 1, 2, 3, 4, 5, 6, 7, and 8. These are the indexes. So if you say I want to have the start index 3, that means we're gonna want to start on this frame here. So we have like some ugly animation that goes diamond shape here, whatever. Here we have something that turns into a circle, like so. So we say we have the start index of 3. That means we're not gonna get this one, or this one. These will not be included in the animation. So we will start on frame on index 3 and go 2 animations, 2 frames up. So if we pass these in here, num frames is gonna be 3, and the start frame index in the image is gonna be 3 as well. We start there and we take 3 of these. You can have animations that stretch many rows as well, like sorry, from there, and these 3 as well. Man, that's not good. My throat is like really really dry now. So we can continue here. Frames J, correct, X and Y, and the width and the height. Set the frame time milliseconds to frame time milliseconds as we pass in here. We will set the clip rectangle, animation frame, set the frame time. We found a frame within the animation. All frames are counted for. We're just gonna break out of the while loop. Here we go to the next frame in the texture. If we pass the width of the image, we will go set x is 0. So if we grab the first frame here, increase the size of the brush. Grab this frame and this frame and this frame, and then x is 4. We are outside here, this space here. That means we are going to reset x. So go back and put x here in the beginning of the corner here. And what we're going to do now, if we have exceeded the row, we will move the y position down as well. Reset x to 0. And we say that y plus equals height. So that means that we go right to the row here, and we go down one height. So with the x point, the starting point is now here, so you can start grab this frame here. Go to the next frame in the image. Like so. And if we're done, we will set number of frames in the animation. Entity dot animations, animation index dot num frames equal num frames, like so. Return 1. Ooh, it's a long function. It looks so good, isn't it? Okay. We can put this on first here, like so. Just because I want to. And we can just copy this, then there, and there's no. We can copy that thing up here. That's less typing. And you have the animation name here as well. No, we don't. So we can just put that back here and do like so, and check the animation name. Parameter show animation name is no, like so. If we don't have a valid entity name here, sorry, value parameter. It's negative. And then we're gonna go for I equals 0, I up to component animation entity dot non-animations plus I loop through the view all animations. If the component is found, not the component, if the animation is found. String compare component animation entity dot animations I dot name. If we have found that stuff, if that is equal to 0, then we return the index. If the animation was not found, turn -1. It's not a good morning when it comes to my throat. I'll do that one first. It should be fairly similar, I think. So just gonna copy everything up here and throw it in here. But now we're not going to return any indexes now. We're just going to say that the component animation entity dot animation state is going to be equal to I, and then we return. Call the function why, so we don't loop and wait to loop through everything else. If we found what we are looking for, we don't have to continue looping through all the things there. Yeah, that's that function. And set the frame time. We're gonna copy this this one at least, and we're gonna check if the animation index, and we have it up here. Yeah, you can get that one for free as well. gonna be less than or equal to 0 here. Maybe we can just grab this one as well. We need this one as well, so we can copy that. And so, and negative. That's right there, good. If the animation does not have any frames allocated, component animation entity dot animations and animation index dot frames. We can use SDL2 MSG512 as usual, and I think we need another check as well up here. Yeah, I know this it's okay. You can do that. Yeah. Printf MSG and go error in function. Frames pointer is null. Animations, animation index, and here comes my door in dot name. Here for dot name. We're just gonna write that to the log. You have to wait a bit. MSG, and we go. Log.txt. So I'll be having a natural break here now and be back shortly. Okay, let's continue here where we left off. We are writing some stuff here. Log the error, and we are wrong line. Exit out of some new software update, whatever. Okay, exit out of the function. So what do I do here? Return. If the frame is larger than the number of frames in the animation. Frame is larger than component animation entity animations num frames. We'll copy some stuff here. Let's say the parameter int frame larger than the number of frames in the animation. Present s. And we copy the line up that way. I have it already there because I copied that thing before. Okay. Exit. And once we checked all these things, we're just gonna say component animation entity dot animations, and then the animation frames for that, and the frame that we want to set, and will take milliseconds for is going to be equals to frame time milliseconds. So 1, 2, 3, 4, 5 checks before we do anything to make sure we're not messing things up. Okay, let's write the final function now for the component animation here. Comma j equals 0. And of course, as usual, we're just gonna grab this one. Less typing, and we're just gonna say, well, not equals to null is better, so we don't have to care about this stuff. Loop through all the entities in the component, max entities, if the animation is not null, I dot animations is not equal to null. We will loop through all the animations that exist in this one. We're probably going to use this one a couple of times so we can copy that quickly. Dot num animations. If the animation frames are not null, animations j dot frames, of course. That's not null. We would free them. Free component animation frames, like so. If the animation name is not null, name is not equal to null, we're going to free that as well. Name. I need to write a reminder here. Texture. Textures are not stored in the components themselves. Therefore, we will not free the memory. Texture pointer is pointing to. Free the animations. Like so. And finally, we are gonna free the component animation. Components, basically. Like so. How many build layers do we have now? Like 1,000,000? Whoa. Yeah, we missed a lot of things on write log here. Well, we can fix that. I guess you guys saw this coming. I didn't. Oh no. With so how many areas are left? Whoa, quite a few. Expected. If I start, oh yeah, don't have a space in between there. Man, it's really spell things this bad. And here, when I throw that in, run log, run it log thing as well. A few less errors, I hope. Yeah, it's almost building now. Well, it's building, but we got some things to have a look at. Return with a value, of course. Hopefully this is the final thing to fix before we move on. Build. Yep. Looks like it. Or not. Get animate. Well, this has been int, of course. So what I just did was mess up my code a bit. Here we go. Int, of course, because we want to return the index there. And I'm gonna conflicting types because this is supposed to be an int, like so. Set animation state. Well, that's a better one to remove these guys from. Return. Get the same thing here because I just copied and pasted all that code before, and I missed a semicolon. Build. Yay, we are building. Build clean, build rebuild, just for fun. To make sure we didn't have any extra loopholes. Build. Looks like we are fine. Yep. Cool. Now it's time to get back to writing our... Okay, we have to check our component stuff. I want to check a thing here. Just gonna look for this one here quickly in the code and see when we find it. Yeah, if that is false. Yeah, I think that's okay. This is the thing we are looking for. Or rather, this is going to be cold anyway, so if we have a look here, we're not returning anything right now like we did before. So here we return 1, we return 0 if we fail there. But it's better to change this code here a bit. I have a look in my notes as well here. Yeah, we're just gonna do like this. We are gonna take this one, just run it, and we're gonna check if the scene malloc failed. If that is 1. We don't have to flag, we don't need to care about this one because we have already flagged this one up in our components here. If you have a look in the here, scene manual fail, we're setting that in each and every component. So we're gonna do a little bit more refactoring here quickly. This guy up here no longer has an int. We can change it to void, like so. Static void, and we don't have to care about anything here. We're just gonna say return one. Well, return. You don't even have to return it. Just do whatever you like now. Like so. Build. Yep, seems to work fine. Okay, let's head on over to our component.h file just to make sure that we have included our things here. Component H. Yeah. Here we have to add our file first and include component animation.h, and in here we have to increase our type count to 8. Important, every time you add a component to this list, you must also increase component count with 1. Exclamation mark. Well, it's up there. Who cares? Okay, so let's add our new cool component here. It's gonna be set1 animation. Like so. Now we added that, and that is included. Good. Now we can start to write our system. All these nifty things here. Not add files. I always do the wrong thing there almost every time. Okay, ECS, entity component system. I'm gonna write new system. That will be system. Well, what caps? System animation .h. I'm also gonna need a C file for this. Yes, please. ECS scene. Sorry, system animation.c. Here we go. Cool. If in def, if not defined. We want to define it like so. Cool. And as usual, in our H file, we are going to add the same things that we do for every other file. I'm gonna bring up my notes here as well, just to keep track of where I am. If you remember in the system here, if you go to system.h here, we have these 4 definitions here that we have to follow. This is like the patterns we're using for in function update entity function, and entity function pointer and free pointer there. So yeah, follow that. Oh, caps is nice sometimes, but not now. System animation unit. This is taking the void scene here. Void system animation update entity like so, and we have a void system animation free. These are the functions we need, which every system consists of. Like collision system has them, entity has them, some has a few more extra things as well that we want to use, but usually it's just these 4, as you probably already knew. Okay, system animation here. Include, like our standard label and stuff. Could just go to something like the animation system and copy whatever we got here and modify. Did we not get that one? Okay, home place. Collision.c, I want to copy these things here. Get back, and I want to paste them. Right. a logger of the timer scene. Here we're gonna system animation.h instead. So we save a few moments there. We're going to define our system animation mask set1. It's basically just gonna consist of component set1 animation. Static in scene T is what we're gonna have as well. The scene is gonna be null. It's a local global pointer to the scene. And we also have a local global pointer to the data. Static component animation T, anim components. We have a null in the initial state. Under 2D. I don't know if I need this one, but we'll add it there for now. I'm gonna have our local variable for system failure. Stack it in system failed to initialize equals 1. Yeah, and also our usual static void update component pointers, which we use for everything in each component, each system. Sorry. There is no scene. It's gonna go return function. And we can go to the collision system here and just, sorry, wrong place, copy a few of these and change them basically. System animation, you're just gonna go anim components here instead. Now that on the components, it's good to have that as well. Good. Now, before we do anything else, I think we should go to our cool scene here and add all our nice things in here. Here's the keyboard components and everything else, and we want to add our collision here, please. Not name tag. Good, we got that corrected, and this is gonna be the. Okay, I just messed up there. Name tag. This is the collision component. Like so. This is the animation component. Animation. New animation. Cool, you're done. Copy a little bit of that and then change this to the animation component. Set1 animation. And I'm gonna say component free animation. And the typecast will be to animation T, of course. And that one's done. Here we have our animation component again. There we go, allocate more memory. Cool, that is done. We're also going to add our animation here. And we need to add a pointer here as well. Animation T. We get the animation T from, we got the data and we move everything forward. Or rather we take that place. If we remove something, just insert it at the right place. We move the entered index. So I've gone through that before, so let's go down here. If you want to recap, we can go to some old stuff. Fallback. Hey, we don't have our add system to scene. Don't we have our collision here? Yes, we do. Just hadn't changed the label up front there. Animation system. We haven't created this one completely yet, so it's going to be called system animation. So we'll get back here after we have finished setting up the code for the system here. System.h is a good place to go as well. Define system animation. System for animation. For animating entities is a better description. Cool. Okay, let's get to our stuff here. System failed. Shall I claim that it hasn't had a problem with that, but yet, which it hasn't. Initializing animation system. Unlog.txt. If the scene is null, error in system animation unit. Could animation system fail? Parameter void scene is null. Put that into run log. System failed to initialize. Fly back to 1 and we just go return 0 here. Tap cast scene to the scene T pointer here. Like so. Gonna make sure it has not collision. I'm writing animations. Come on. Animation components. Get component. Let me see. Only set one animation. Thank you so much. So now the animation components. Oh dear. We need the scene does not have animation. Let's go for that. Run log like txt. Okay. Who system failed to initialize. Give it 1 and we will return 0 here. I think I'm gonna skip the render components for now because I don't think we're gonna need them. But in case, we're just gonna leave it there for the moment. Turn 1. So all we really care about if the scene has animation components. That's all that we require. And update here is as usual. If the system failed to initialize. If that is 1, we're just gonna return. I don't care about anything else. If the component pointers has been reallocated in the scene, we are gonna do a nice we update component pointers here. Sweet. That means we don't have to dereference them every time we are going to access them. We just update them when needed. Okay, update entity is going to be a bit different. In current frame index equal to 0, and I say, oops. If the system failed to initialize, just this guy up here, as usual. And we're just going to return, we don't want to do anything. If the entity has the animation component, entity dot component set 1, use the and their system animation mask set 1. In case we are adding more to the animations later, we want to be able to have a mask that we can add things to. And if the caps. Sorry, if the entity, or rather if the animation has an animation component rather. That is larger than 0. We know there is some animations there. If it is time to go to the next frame, timer update. This is where we use our timer. Anim components, entity dot animations, anim components, entity dot animation state dot frame time. If it's time, if we have past the duration for the frame, then we want to go to the next one. So go to the next frame. Entity, dot animations, components, entity. Animation. The animation state there. Dot current frame plus plus. And I'm gonna copy this thing here. Check if animations current frame larger or equal to num frames here. If we have passed the number of frames we have in the animation, we want to go to the next. We want to loop it back. We're going to reset to the first one. Current frame equals 0. That's what we're going to do. And now you have to copy frame index. And this for easier readability. Code below. There we go. Timer init. Anim components, please. Entity dot animations. Anim components. Again, this is a pain in the ass to write all these extra things. Animation state, and then you get the. So it's good practice. Oh, animation state, but frame time, of course. And then here comes the super long line here. Anim components, entity, dot animations, and we get the anim components. Entity dot animation state dot frames. Never use the current this, otherwise I've had to put this whole line here inside of here to be like a super long thing here. Frame time milliseconds. Whew, there we go. How many errors do we have when we building now? Like a million or a trillion? Component free animation. What did we call that one? It's right here. Aren't you added to the component animation here? Yes you are. Or you're not added here? Yes you are. Ah, too few. Yeah, come on. I need the scene. Max entities here, not components. Entities, thank you. Entity, there we go. Bill. Cool. Now we have the system up and not running, but we have the system in place. Go back to the scene here and make sure we are it's a free part, and we are talking about the systems before, so let's find that place. It's right there, and you get components and here and there. Oh, okay, here we are. This is what we're looking for. Animation system here. Here, this is going to be the system animation, and it has system animation in it here. System animation update is what you want to be calling there on that time, and system animation Update entity. The system animation free. Not free with millions free, but free. Cool. What else we got here? The scene systems, that's okay. And I don't think we have the collision system here. System animation, we return the system animation thing. I don't really use this function a lot, but we can still update it for safety. And here we are gonna type the basic component set collision and component set animation. Set one animation, cool, and the bits and everything. Okay. Whew. Now make sure we are building okay. We are now. Did I not add these things to our system file.h here? Oops. No, I did not. Of course it can't find those. System animation. I added it here, but I did not add the H file here, so build. Okay. System animation. Okay, it's called free with an extra E there. Let's fix that. Was kind of funny. System please. Free. Oh, yeah, nothing's gonna happen in here, so nothing to free. System does not allocate any memory. So copy that little friend there. System animation H and find the system animation H. Here we go. Free with 3 E's. That's nice. Or not. Good, we are doing everything we need for that part. Now we have to go into our system render ISO world thing here and figure out what to do next. Shouldn't be too much, but a few things at least. We have to go into a draw code. In this one, system render isometric object is a good place to start. And here this is actually be a pointer to null now. We're gonna change a few things here. And we're gonna need the animation T here. For anim, you can call it like that and say null. If the entity has the animation component, entities, entity, for a set and check if that's true. Animation. Point the anim to the animations. Point there, so we don't have to type all this stuff all the time. Now we get the texture. Texture is when you get to current animation. adding components, entity, dot animation state, dot texture, and we set the clip rectangle to the current animation frame. Texture clip rect equals current animation, animation components, entity, dot animation state, frames, and animation and components, entity, animation state, dot current frame, dot clip rect. Ooh, it's a long line, but we got it out. Else, okay. There's a render 2D component. Component set class A. Component set, where are you? Maybe just copy that thing up there and don't have to look for it anymore if I need it. Let me just set the texture. It's gonna be equal to render to the components entity dot texture. Like so. Else, we're just gonna return because we don't have to care about drawing anything if it does not have any stuff here. If return if the entity does not have animation or render component. We don't want to do anything. We don't want to do extra computation for things that are not needed. Cool. So it means we reset the texture clip rect and everything. Good. Now we gotta fix another thing as well. I'll find that in my notes as well. Down here, I think. Yeah. System render isometric world sort entities we're gonna go to. Thank you for finding that for me. And in here we have to do another check as well, see if we are with the entities. Entity dot component set, if it has the system. Oh, we have to create that mask as well. We have not created the mask yet. So we can copy this little friend here and we can say define render isoanim mask set, and we need the position and the set one animation here. That's what we need down here. Like so. Let's see here. Get the zoom one. Okay, here we're gonna add some code. If the entity has an animation point, scene dot entities, entity component set, animation.
We're gonna add the current animation thing up here as well. And also SDL rect. Anim rect. And we're gonna need animation T. Cur anim. It's gonna be null in the beginning. That's a binary search thing. That's not what I'm looking for. I just skipped it. Here we go. Pointer cur anim. Pointer to the animations. More readability and less typing as well. Anim components. There you go. And I want to get the animation rectangle. Why? Well, because we want to know the width and the height, so we can check if the thing is on screen or not. So current, sorry, anim right equals to cur anim components entity dot animation state dot frames current animation of the animation components entity dot animation state dot current frame dot clip rect. Ooh, these guys are long. Get the animation rectangle. I just did that, man. I mean, if the point is within the screen, is what we're going to do now. Things are getting late here. I record in the morning and now I record in the evening. So it's always some good excuse, no matter what time it is. Oh, it's midday, I had to work a lot, and whatever. Well, ISO engine. Zoom level. That is lower than 0. And let the point dot x less than the window width, and the point dot y plus animation rect dot height multiply by the ISO engine zoom level it's lower than 0, and the point dot y is less than the window width. That's the window height. Then we know we can actually set. Okay, flag. We're gonna add a flag here. On screen, we're gonna say on screen equals 1. So that is up here as well. Quick paint. Nice. And then we go if not. We want to do all this other garbage here, which is basically this stuff here. And then we're just gonna go in F here instead. There we go. Animation. It's not an animation. Flag that the entity is on screen. And if the entity is on screen. Okay, how many errors do we have now when we build? Anim components has not been declared because we didn't add them. So let's do that. Component animation T. Anim components is null. Let's add these guys up to our nifty place here. Get the animation components pointer. Basically the truth. Component animation G. Component set animation here. And we have to add this to the initialize function as well. There we go. And we can check if that is null. We're just gonna do have a. Wow, this is collision here. Sometimes I haven't updated my comments here. Not good. Animation components. Animation component data is not allocated. Why do you have like an extra space in here? Good question. You can always clean up code later. Code components. Yeah, let's put in component then. Animation components. Animation component. That's better. So in order for this to not fail, we want to add our stuff to our C file, wherever you are. Where are you hiding? Here we go. Static. Component animation T. Animation equals null. Should really rename this guy. I think I did in one tutorial and then the code messed up, so I had to rewrite a lot of stuff. So I don't remember. I think it was a only for the refactoring thing or whatever it was, but. No, animation please. Get the pointer from the scene. I could just copy that line above. In animation, you can add it whenever you want. Animation, we're gonna add it to the scene, and we're gonna add a system here. Animation, input move collision, render. Well, we want to animate before we render, I think. System animation. Cool. How many errors do we have? Expected. Yeah, messed up there. Build. Cool. Can we even run now? Sure we can. Well, the game runs, but we are not drawing anything because it's gonna look like this for now. Collision works, but we don't see anything. We're gonna get to that. Hopefully, really soon. So we're sorting entities, we're doing this, we're doing that, and gotta think a bit where we are in what we are doing. System animation is running there. It's supposed to be running at least. I'll make sure that we are drawing something. Just because we registered that system should mean that we are not drawing things. Here, let's see here. sorry, just looking at my notes there quickly. Shouldn't be anything else than that. Interesting. Well, we can continue in anyway. Let's see here. Draw the collision boxes and stuff, and they should be drawn at least. Yeah, well. Just a bit baffled that we are not seeing anything on screen, so it's always fun when things like that happen. Gonna double check here very quickly. I'll be back in a short while here. Gonna take a quick break and sort things out here. Yeah, I'm back. The reason why we are not drawing anything is because we are checking for the animation thing here as well. So if we go run the 2D and build and run, we are gonna see our character here. It's normal. Now I'm gonna make sure that I have the right file here so we can have a look at the animation things. Let's see here, gonna bring up thing quickly here and have a look at this. That's the folder I'm looking for. That's the file I want. I'll copy it into the right folder here so you can actually use this for. So basically, this is the animation sheet that I drew. The character walking around. Not the best. I'm not a pixel art guy, but it took me some time, but it was fun. References is king, I can tell you. So if you want to draw something like this, find some Diablo 2 or Diablo 1 references and draw away. Okay. Now that we got that down and out of the way, we have to add some things to our initialization things here in Isometric tutorial pod stuff here. Characters we're gonna look for, and we don't need this guy. Character 2 is gonna be deleted, so we're gonna use this character PNG I just showed you. I'm gonna look for that character again, wherever he is. There's probably gonna be a few changes here, but you're gonna need the character here. Texture pool. So I'm gonna get things right here and system. Here we have it. It's right here in my notes somewhere as well. There we go. Want to make sure we get this right. Well, this guy here is going to be 70 by 70 instead, because the character is not 102 pixels large anymore. And set the texture to render, and set component position offset, position set offset. That's what I'm looking for. Position component and the entity, and go to -0 and the -4 on the that place. And here comes the fun part. Here we have all the idle animations here. Animations, which is currently just 1 frame at the moment. Entity animation. Whoa! Gonna create one of those things, I guess, as well. I want to keep track of which entity was the last one we added, so sorry, the last animation we added. Entity animation doesn't matter. Okay, I'm flipping through the wrong files here. In it, here we go. It's not supposed to be up there, down here, and here we go. Entity animation going to equal to component animation, create animation, create new animation basically. Animation entity, texture. For the pool, get texture from pool. That's what I want to have. Game.texture pool, and I'm gonna get the character.png. I'll up left. So I create these animations, and we're gonna go component animation, add animation frames. Animation and entity animation. This is the guy that we just this function returns the last entity that was added, the entity animation that was added. So we just throw this in here, so we know which the entity that was just added. So it's easy to keep track of that. And animation index. See your entity. Oh, sorry. Here, entity. Of course, then the entity animation index. This is the index we got from adding that file there, and the entity is the one we're working on, of course. And width is going to be 70. There are 70 by 70. All these frames. The frame num frames is 1, and it's going to start at the first first guy in top. This is the first frame up here in the corner. This guy right here. So now basically what we are going to do is just add all these animations in here. There's going to be 8 of them. 8. It's going to be a lot of repetitive stuff here. This is just the idle ones. So idle up left and idle up. Up right. Idle right. I'm using this in the order they are coming here. So idle up left. This one, and up right, down, left, and left. So that's the order I'm using here to get things sorted out, basically. Idle down right. Idle down left, and idle left. So now we just have to add easy 0, 1, 2, 3, 4, 5, 6, 7. So that's easy. This is just one animation for one frame for those animations. Now I'm gonna copy this stuff here. I'm gonna do the walk animations here. walk animations. Currently, lots of frames. Well, they're gonna be 8 frames. So the first one, you see, this is 7, and each of these animations are 8 frames. You can change this from 1 to 8. Because all of them are 8 animations, and this is gonna start on 8, and you guessed it, 16, 24. It's very simple. We just add 8 frames for each of this. 48, 56, and 64. I'm gonna all of the frames are gonna get 100 milliseconds. And we're gonna go with walk. Down. Walk up. Walk left. Walk right. Walk down left. Walk down right. Walk up right. And walk up left. Like so. Now for starters, we're gonna set component animation. Animation set animation state here. Animation and that's the component. There we go. And the entity and idle. Down is gonna be the first animation that we set things to. And entity up direction equals entity well direction down. So basically it's going to be a big difference here. Spin around, it's going to be standing down, but you can see here we have some nice artifacts there. So we're gonna fix this up. And if you wonder why it looks like this, it's very simple. I'm gonna show you why. And I think we have a crash in the program. Yes, we do. Can look that up soon. But we can go in here now and change all these things in the this is actually in the input keyboard place where things are happening as well. So we're gonna go here into the control ISO world, because we are setting all these animations here. Oh, sorry, control entity here. Here we are. This is hard coded at the moment, not so pretty. But if we are the player, then we will do this and that. So I'm gonna do some changes in here. And just for fun, you might want to see an animation first, which I hope this is gonna work. If not, we'll get to it. But you can set this to walk down here first. Walk down, build and run. It doesn't work, so I have to look at things. Why? Things are not working. I'm gonna find out why this is crashing as well, because I don't know why. Moment. We can go debug and start continuing and see where it breaks. Debugger. We can have a quick look here and see where it sort of crashes. It doesn't say, but we'll get to it. Might be something in the log file that we are missing as well, so I can have a quick look at that before we continue here. It doesn't say, so well, things can crash and burn while you are playing around with them. now it's crashed really well. That's okay, I'm just gonna end the program and we can get back to coding and performance processes. I don't want the processes, I just want to kill my program. Name. Where are you hiding? Very strange. It doesn't allow me to. Well, I'm gonna get back to this really quickly, just to have a quick break and get things working properly again before we continue here. So we'll be back shortly. Okay, let's continue here, and we are gonna go to the control entity function here, basically. And what we're doing, we're cutting all these rectangles and stuff out here. So we're gonna change that. And just gonna bring up my notes so we are at the right place here, so I know what to do. Almost there. Keyboard control, yeah. So here we are. We're gonna change all of these to match the walking speed of this guy. So it's gonna be a little bit different here. 100, I should be able to set these guys in a function instead, but we have not gotten to that yet. We're just doing some simple stuff here. 100, 100, and here we go 50, because it's just half of what we had before. And 50, like so. That's the first thing to do. Then we go up again and start from the beginning. And here we're gonna set the anim components. Select entity control, dot direction. Going to be equal to entity. Down right is the first one we're doing. And here we don't have to do all these crazy things now, because we're just going to go and say set the animation state for the direction. For animation set animation state, get the animation component, we get this, the entity, and we set which one we want to do. Walk down right. What we're going to do here. We are going to add a few things as well here to the collision here. Go to collision.c first here. Short, that's colliding. Is the entity colliding this frame. Gonna do component collision here. I'm gonna reset those things as well. We have the new one. Here we go. I dot is colliding equals to 0. Cool. Same thing has to go in here. J dot is colliding equals 0. Thank you for that. system collision. Entity, I think, is what I'm looking for. Update entity, yep. Here we can say that. Here, I'm gonna reset. Reset is colliding to 0. Collision component entity dot is colliding is equal to 0. If the collision detection is not active, for entity collision type deactivated. We're just going to return here because we don't have to do any more things. Auxiliary function. Then we go down into handle entity here, collision, and then here we just say the code components entity dot is colliding is equal to 1 because we have collided with something here. And if we are in the other place here, in the checkpoint collision, we do the same thing here. Colliding equals to 1. Flag that the entity is colliding. Like so. So one good step, and we can go back to our system control entity here. And here, and we can get this colliding thing here to I'm gonna add this just up here actually. If the entity has collision component this is selected with control that is colliding. Sorry. No, this I have to check for the component set here, yeah, first. And component set 1 collision. If we are colliding, we're gonna set this colliding to 1, and we're gonna add this up here as well as a quick int or short, doesn't matter. Short equals 0. And if we are colliding, we're gonna do. Okay, if we're not colliding, we want to use the walk down right, else if the entity has collided something, we're just gonna set the frame to idle down right instead. Cool. Remove this old code here that we don't want anymore. Copy that stuff. Well, actually not all of it, just this. This one we keep, and then we have to set this guy as well, so I should probably move this one like so for easier copying and pasting stuff later. Like so. This is not down right, this is gonna be upright. Because it's right and up first. It's gonna be idle upright. This is walk up left. Lost my voice there quickly. Strange. I'll walk up and press. There, up left, of course. This is down left. Idle down left. Gonna add this guys and see if we are animating. If not, I have to take a quick break and see what I done wrong. Direction up, please. Walk up and idle up. Down. Idle down. And we're gonna go and get idle left here. That's our directional left. Walk left. Idle left. Just the right key left now. Pull. Right. Walk right. Idle right. Build. Collision question is, do I even have them up here? Not component input. Well, we need to add them here. Component collision T. So we have to add them to our nice thing here. Component collision. Let's just copy that and be happy. Run the collision. Component pointer, please. We have the collision components. Well, log is an error if we can't allocate. So, what about now? Call components, thank you. Build. Anim components. Yeah, I haven't even included those guys yet. Static anim components. We need these guys as well, because we need to do cool things. Get the animation component right there. Component animation T. We want the animation. I'm gonna copy these two lines because we're gonna need them down here as well in the initialization function. The animation component is null. Cool. Build. Expected. Of course you are expecting that. Anything else that's expected of me? No. Gonna go and build and run and see if this little friend is animating. And it's not at the moment. So I gotta get a quick break and look what I missed. So I missed something small somewhere. So we're gonna have a look at that. See what's going on. So a quick break and I'll be back real soon. Okay, let's get back to it. So the reason why we're not seeing any animations is because we have not added this to our component. We're gonna add this one here. Component set one animation. That's why our entity was not displaying animation. And we're gonna check one quick thing in here. Yeah, here as well. Why we are crashing is because we forgot to put our J up to our number of animations there. So we go build and run now. Of course we are missing one of those. Build and runs. And now, as you can see, we set our start animation to be idle there. But if we are releasing, we're still walking in the air, so we have some little things to do. But if we crash into something now, it will stop. Which is nice, but we need to make sure that we are not walking when we are releasing the keys. Sorry, that we stop walking when we are releasing the key as well. So for this we are going to add a timer actually in our keyboard input component here. Where are you hiding? Over here, component. In here we are going to add our stuff. Then we're gonna add a thing here called timer T. Action release. We're gonna have a release timer, so that if we are pressing two keys, we will actually be able to track that a bit as well. So how long to hold actions. The previous actions array. So what you're doing when you're pressing a key is you're going to add it to our small array here. Previous actions. We just need two of them. We might extend this in the future, but for now we just need two. Which action that was previously fired. So this means we have to add these things into the input keyboard here as well, and we're initializing things. Wow. New component input keyboard, J dot action release. We want to have that one as well. We're gonna go timer init on that one, and we're gonna set like 150 milliseconds for the action release, and we are going to set dot previous actions -1 is just 2. It's just more coding to put a for loop for 2 indexes like this, so we're just gonna do it like that. And I'm going to copy these guys here, and we are going to go up here, throw them in here, and of course we can't because there's another name here. But it's okay, it's a quick fix anyway. Dot previous actions 0 equals -1 1, and we have our timer here. Timer init dot actions release timer. There we go. Initialize it to 150 milliseconds, like so. Checking quick thing in my notes here to make sure that I'm using this properly. Yeah, don't gonna need that, I guess. So I'm mumbling for myself here. I need to know where I'm using my things here quickly. Where to adapt them. Yeah, over here, I guess. So, I'll look here in my stuff. Keyboard input, I need to find where I'm supposed to put my things in now. Okay, this is the wrong place. I need to be in the control entity here. There's not a lot left. Just a few minutes and we should be having our things up running. Else we are gonna do component keyboard. Isn't that one? Sorry, if the control entity is the player, this is what we're gonna do, yeah. And if animation components, select entity control, dot direction, entity direction up. If the control entity is the player is facing up on the screen, keyboard component selected, entity control. I know what I'm gonna look for now, and it has to be this. I'm gonna type here in a few seconds here. Yeah, you have to go in here as well. That's why I was here before. I had it in my mind, and it should be up here. The system free. Input system is where I want to go. System input. Here's our friendly place we need to be. And here we're gonna set the previous actions, previous keyboard actions. Keyboard components entity dot previous actions 1 is gonna be equals. We got previous actions 0. We're just gonna copy these ones down. So each time you release a key, you will have a small stack of them, basically. So that was the thing I was looking for. I had it in the back of my mind here. So component input keyboard. That's not the place I want to be. I want to be in control entity here. Okay, up. Previous action is 1. You move move right. I can just move left. That's the one. That's the thing. How I remember it at least. Start with left and we go. Idle up left. This is if you release the directions keys. You're pressing up and left at the same time. You want to stop in idle left. You want to set the character to idle up left. Basically. Key move right. And when it's up to sorry, this up. Idle up left, of course. Don't do stupid things, man. Else, just gonna set it to idle up here. Idle up. If or facing down. Facing down. Just copy all this stuff here and reuse it. Key move. Left. You just keep that. Idle down left, of course. And idle down right if we are pressing right. Otherwise it's going to idle down. Like so. Oops. There we go. Coding late at night is not on the best, but it's you get things done eventually. Left. If we are moving keyboard up, this should be keyboard move down. No, up, left here. Or go down or left. Otherwise, I'm gonna idle down left here. Or no, just idle left. Idle down, down. Then go down left. Down, idle down left, idle down left. Yeah. Copy is facing left. There we go. Direction right. Idle up right and idle down right. Or just idle right. Yeah, we're gonna write a function now in our H file here for the component in the keyboard here. It's gonna be a new one. Component key and board. Is here that really what I'm looking for? Yeah, I think it is. Component tree input keyword component. Yeah, component input key. We're just gonna type it to some. Keep the standard here. Input keyboard. Update action release timer. Input keyboard. Just copy that stuff up there. It's easier. And put it in here. I'm gonna say if component input keyboard is not equal to null, we will do our stuff. Timer update here for the entity dot action release. If it's time to update that thing, we will go and do our component keyboard entity dot previous actions 1 equals component input keyboard entity these actions. Here we go. I think we can remove these guys from the other place here, or not. We'll try this first here and make sure that things are working properly. Yeah, we're gonna send in the -1 here because we can't do that because we have to update things like this. So we are sending in a -1 here and we are copying the old action up here, so it should be fairly okay. And input keyboard H here, like so. Then a system input here. We have to run this function as well. We should run it like in system update entity, I think is a good place. If it's active, here we're gonna run it. Update the keyboard action. So the action release timer. We can call it keyboard action release timer, that's okay. Keyboard action release timer. I'm gonna run this guy here. On the entity, like so. Okay, let's see if this string is okay. We need a timer here. Include timer, thank you very much. Pulling this some ampersand or something, I don't know. Right. Oh yeah. That is equal to. How did we miss this? Is a very good question. Sometimes we are coding blind. Fill and run. Here we go. Here the character is walking around and we are stopping and our directions. No. I think we need a few more if statements here somewhere. Yeah, have a look at that quickly. Why let's get that and control entity here. Yeah, we got 4 little ones, 4 little else ifs here. Yeah. and components. Selected entity control dot direction equals entity direction up left. Title up left. So you're gonna need 3 more of these. 1, 2, 3. Up left. Up right. Down left. And down right. Oops, save. Now we can rebuild the whole project, that's good. See if we have some other problems. Now, build and run. How are we faring? Let's pull this thing here. And we are now... Okay, it's still not behaving as it should, so I should probably check the order for things here and see if there's a difference between what I've done before and now. But I don't think so. I might be missing something somewhere though. So I'll be having a quick break to see where that problem is and get back to you here. Okay guys, I think I know what the problem is, and we have a small little function here, one more, in our component input keyboard system here. So we actually need to update our timer here. Update action release timer. So the funny thing is that we have to write the same function, but we have to call it int here instead of update. And we need to go for component. So we can just copy this guys here. And this is gonna be init here. If it's not equal to null, we're just gonna go timer init. Our cool little thing here. The action release. Like so. And I'm gonna go 150 here as well. For our stuff. I'm gonna copy this guy here. Input keyboard.h, and we throw him in around there, and we're gonna copy this guy here. We're gonna go to our control entity function here. And we're gonna find, yeah, right up here. We need to update the release timer here. Update the keyboard action release timer. Question is what we have. We have the keyboard component here, I hope. Component. What's the name of it? Keyboard input components. There we go. Comma. Entity here. Like so. And now I think that we should be good. Well, of course not the entity selected entity to control here. Now we go build and run. So have a look now. We run this guy again. Yeah, we are now stopping on the diagonals as well as we are releasing the keys. That's nice. And you can tweak this later if you want to. So this is what we have now. An animating character on the screen, walking around. So this concludes this tutorial, and I hope you enjoyed it. It takes time to do these things, and we have some things to fix, like stuff like that. The little foot sticking out there, but it's minor things. You can tweak those things later and be happy. We can now animate entities as we please, and pretty cool. This is the end of this tutorial, and hopefully I will get another one out in a while. I'm thinking about fixing like a custom resource file where you just take your PNGs and your WAV files and everything, you put it into one file basically, which you can load files from. So you have everything compressed, not compressed, but everything is packed into one file without compression. So you can grab files from that. So it's really good when you're releasing a game that you're not releasing 20,000 files, but you have one big file with like one big data file with all the files inside of it. So that might be the next tutorial, or I don't know. We'll see what happens. That's something I can do or add to this, but we don't want to make things too complicated. I think the next tutorial will have a bitmap font. That would be nice. We don't have text on screen yet, so bitmap font for the next tutorial. Yeah. Okay, guys, thank you so much for watching and keeping yourself updated with the stuff I'm doing here. And I'm happy that you're following my channel. If you like it, please subscribe and have a good one. Bye for now.